sharing my screen with you? Please confirm me if you can see my screen.
Yes, sir.
Yes.
Yes, sir.
Okay, thank you so much. Happy to know that you can see my screen. We studied about heating curve. We studied about other formulas. Now we're going to study about the last part of this, which is the principle of calorimetry. Now, when I talk about the principle of calorimetry, let me very quickly give you a brief idea as to what calorimetry is. A calorimeter. Let's talk about a calorimeter very quickly. Calorimeter looks something like this. You have a vessel which is surrounded by wool.
Nearby.
Mic, beta, mic. No, mic. Mic, mute yourself.
Sir, you can do one more thing. You can mute all of them and make you only when they want to speak. You
But the
cannot
point is, if I don't allow the participant to unmute themselves, then you'll not be able to ask me any question. Chalo, theek hai. I will allow you to unmute a little later. So I'm not allowing any participant to unmute. I'm opening a chat box here on my second device so that I can at least see your chats. Okay. Okay, so first of all, very quickly, a calorimeter is a device, is basically, there is a vessel. The black color line that you can see is basically a vessel. And this vessel is surrounded by wool. This vessel very quickly is surrounded by wool. Wool is a bad conductor of heat. You know it very well. In winter, you wear woolen clothes. So this is basically wool. And then this is covered with a wooden box. This is covered with a wooden box. Now, wood is also a bad conductor of heat, and wood is going to complete the device, complete the setup, and also act as a physical protection. Now, there are two holes in the device. There are two holes in the device, one over here, the other over here. Through this particular hole, a thermometer enters the device. Thermometer will be used to measure temperature, and through the other hole, a stirrer is going to enter the device. See, the purpose of the thermometer is to measure temperature. The purpose of the stirrer is more like chamach. Stirrer will be used to ensure that whatever is inside the calorimeter vessel is mixing properly. Now, what exactly we do in a calorimeter, we mix two or more substances having different temperature. Now tell me, if two substances are having different temperature and when they come in interaction, they will exchange heat. We all know that heat will flow from higher temperature to lower temperature. We all know that. So what will happen inside a calorimeter? Inside a calorimeter, there will be exchange of heat. There will be exchange of heat, and heat will flow from higher temperature to lower temperature. TL matlab, TH ka matlab kya hoga? High temperature. What is TL? TL is lower temperature. So heat will flow from high temperature to lower temperature. Now we know if there are two substances, A and B, and if A is giving out heat, let's say there are two substances, A and B. Now if you look at A and if you look at B, if heat is flowing, if I say that temperature of A is greater than temperature of B, then obviously when they come in contact, heat will flow from A to B. Heat will flow from A to B. Now, if heat flows from A to B, the temperature of A will come down because heat is flowing out. and the temperature of B will go up because B is getting heat. A is releasing heat, so its temperature is coming down, and B is getting heat, so its temperature is going up. Now this phenomena will keep happening until the temperature of A becomes equal to temperature of B. This phenomena will keep happening until the temperature of A becomes equal to temperature of B. Are we all clear with this? Are you able to understand this point? Comment in the chat box. Yes, start commenting in the chat box if you have understood this part very quickly. If you have understood calorimeter, you have understood what calorimeter is, what mixing of substance is, and how heat flows from one point to the other point. Can you please comment? Okay. All right. All right. Thank you so much. Thank you so much. All right. Great. Now, if you're able to see here, that these two substances A and B will be mixed inside the calorimeter. Now, if I make a calorimeter, let's say this is a calorimeter. This is a calorimeter. Now, calorimeter is completely insulated. It will not allow heat to enter and it will not allow heat to exit. If you look at a calorimeter from here, in calorimeter, heat will neither enter nor exit. In a calorimeter, heat will neither enter nor exit. But I have mixed two substances in the calorimeter. The two substances are, we have got A and we have got B. Now, A has given heat to B. A has given heat to B. And the calorimeter is not allowing anything to enter. It does not allow anything to exit. What does this mean? This means that heat given by A is equal to heat absorbed by B. Very simple, right? Because since बाहर से कोई अंदर heat नहीं आएगा, अंदर से कोई बाहर नहीं जाएगा, but अंदर A and B are interacting and A is giving heat to B. What does that mean? कि A ने जितना दिया, B ने उतना लिया. Tell me if you are able to understand this. Comment in the chat box very quickly. Disha, you want me to repeat? What should I repeat, Disha? I'm allowing you to unmute yourself. So I'm allowing you to unmute. So Disha, if you want me to repeat, please quickly tell me. What do I need to repeat?
So that what you are telling now?
The calorimeter part or the bottom wala part, A and B?
No, calorimeter wala.
Calorimeter, the upper one?
No, here down.
The bottom one, right? Okay.
Yeah.
See, try to understand it in this way, Disha. I'll make it very simple for you. Now, assume, Disha, that there is a bank which is completely sealed. No money can enter the bank, no money can exit the bank. And the bank has two counters. There is a counter A and there is a counter B. These are cash counters. Now, counter A has 15 lakh rupees and counter B has 5 lakh rupees. And the bank is sealed. No money can enter, no money can exit. However, A counter can give money to B counter because A is richer, it has higher cash. So what happens is A counter ended up giving, let's say, 3 lakh rupees to B counter. So the balance in A counter now is 12 lakh rupees and the balance in B counter now is basically 8 lakh rupees. But when you look at it in totality, since the boundary was sealed, the total balance before in A and B combined was 20 lakhs. The total balance after A and B combined is 20 lakh. यानी बैंक के अंदर बाहर से पैसा नहीं आया और बैंक के अंदर से बाहर पैसा नहीं किया. However, there is a transaction between A and B. Do you get that?
Yes.
It's an internal transaction. What does this mean?
Yes, sir, I got it. Hello.
Sir, your voice is not coming.
Sir, your voice is not coming.
It is not coming.
Sir, your voice is not coming.
Guys, put off the camera. Yes, you can hear me now. There was an internet connectivity issue. I think you can hear me now. Can you hear me? Please confirm.
Yes.
Yes.
No.
Sir, what was
Yes,
I
sir.
telling you? That in the bank transaction, Disha, को कितना पैसा दिया?
कितना क्या हुआ?
In the transaction, what is the amount that A gave to B? Very quickly.
3 lakh.
3 lakh. How much amount did B receive?
3 lakh.
यानी कि जैसे मैंने यहाँ पर लिखा है, I can again write it that cash given by A is equal to cash received by B. Do you agree with me?
Yes, sir.
The reason that this is happening is because the bank is sealed. बाहर से कोई cash अंदर नहीं आएगा, अंदर से कोई cash बाहर नहीं जाएगा. Do you get that point?
Yes, sir.
So this was the example.
Thank you,
This
sir.
makes us arrive to the principle of calorimeter. The principle is
आम्हाला आमचे
principle of
100
calorimeter
रुपये
is
पाहिजे आम्ही लोकांना दिले होते.
Mike, you got to be careful. You need to follow certain instructions, please.
Sir,
Yes, beta.
sir, I have a doubt regarding calorimeter.
Tell me very quickly.
Sir, as you stated that calorimeter doesn't allow heat to enter nor to exit it. So
From
if we store the
outside.
pack and doesn't allow heat to enter it and nor allow heat to exit it. So if we store packed ice in this meter, so it will melt or it will be same in state.
The point is, if you put ice and water inside calorimeter, then heat will flow from water to ice because ice is cold, water is warm. So ice
Sir,
will
only
melt.
ice, only ice.
Only ice. No, ice will not melt. Technically, ideally, ice will not melt. However, you cannot make a perfect calorimeter because even if you try to make a perfect calorimeter, you cannot have 100% perfection, right? There will be some or the other error. But if your calorimeter is perfect, then ice will not melt because no heat will enter.
And
Sir, I have
sir,
a
it is
doubt.
only.
Tell
Sir,
me.
and we need only liquid, or we can use any other states.
You
in
can
calorimeter.
mix anything. You can mix anything, beta.
Sir, I have a doubt.
You can mix anything. Now let me go to the principle of calorimeter. This is very,
Sir,
very important. Yes, beta.
Can you please solve my doubt?
हाँ बोलो.
Sir, good means can you go upwards? Yes, sir, this one, that directly proportional one, something like
No, this is not directly proportional one. This is wrong. This won't happen.
Sir, a doubt.
And sir, can you explain this box, that what is written in that box?
Which box, beta? The right
A-
box or the left box?
Right box, yes, right box.
This one. This one.
Sir, where you have written won't happen.
Acha, won't happen. See, this is heat. Heat will not enter. Heat will not exit the calorimeter because the boundary is insulated. Do you agree? It is insulated. You can see na wool, wooden. These are bad conductors of heat.
Yes, sir.
They will not allow heat to flow. Clear?
Yes, sir. And how can we, if heat cannot enter or exit, so how can we enter this material, these substances?
अरे we will enter the material and we'll seal it. अंदर
Okay,
डाला,
sir.
seal कर दिया immediately.
Okay. Yes.
ठीक है? Now the principle.
Sir,
Pay
what
attention.
if we create
Sir, a
vacuum
doubt.
and calorimeter?
Tell me.
So what if we create vacuum and calorimeter?
What happens when what?
What will happen if we create vacuum and calorimeter?
A vacuum does not have any substance. So there is no substance, there is no temperature exchange, there is no heat exchange, there is no flow. You need to have substance now. You need to have something for heat to transfer. There has to be a substance at higher temperature, there has to be a substance at lower temperature. Okay? So we will not talk about vacuum in this case. Put off your
A
mic,
doubt.
put off your mic.
Sir,
Yeah, beta.
sir, is thermos based on calorimeter only?
Absolutely.
Sir, during heat exchange, you told that the heat transfer is from hot object to cold object.
Yes.
But if the temperature of both the objects does not become equal, it will not stop.
It
Right?
will not stop. Yes. The process will not stop. The heat transfer will not stop until the temperature of both the objects become same.
Because I had a doubt you didn't add that point during explanation.
Okay. Is that clear now? Is this clear to you, beta?
Yes, sir.
Yes, sir.
Great. Now look at the principle. What does the principle of calorimeter say? Principle of calorimeter say that heat released is equal to heat absorbed. As simple as this. Heat released is equal to heat absorbed. I hope this is very clear to all of you. Abhi kiya.
Yes, sir.
Right? Now I'm starting with the numericals. So now going to the numericals, I think heat is your 5th chapter, right? So I will directly take the first numerical, and you need to pay very high attention to the approach that I'm using to solve these numericals. Now there is this question. Everybody open your textbook, page number 72. Science 1 textbook, page number 72. Solve the following problems. Science 1 textbook. Mic band, put off your mic. Put off your mic. Okay, so that's question number 9A. Can you see this? Can you see this particular question?
Yes, sir.
Okay, now I will read out this question. The question says equal heat is given to two objects A and B of mass 1 gram. So pay very high attention. There are two objects here. We have got object A and we have got object B. Now equal heat is given to the two objects. Equal heat is given. Let's say the heat given to both the objects is Q. Let's say the heat given to both the object is Q. Equal heat now, so it becomes Q. The mass of both the object is same. It is 1 gram. Okay, it is 1 gram. All right. The increase in temperature of A is 3 degrees Celsius. So I will write change in temperature. So the change in temperature of A is 3 degrees Celsius, whereas the change in temperature of B is 5 degrees Celsius. Okay. The question is, which object has higher specific heat? What does it say? The question is, which object has higher specific heat? Now, specific heat in your textbook, I generally use S for specific heat. However, your textbook says use C. So I'll be using C henceforth. So it says when it comes to specific heat, let's say the specific heat of A is Ca and the specific heat of B is Cb. Which object has higher specific heat? Now, when you look at this phenomena is heat is given to an object and its temperature changes. Do you agree with me?
Yes, sir.
Heat
Yes.
is given to an object
Yes.
and its temperature changes. Now tell me,
पैसे
which
कब
particular
मिलेंगे?
formula?
100 रुपए.
1 second, put off your mic here. Why can't you understand? You need to follow certain discipline. Okay, so now the thing is, heat is given to an object and its temperature increases. there are two formulas. We had two types of formulas. One was Q is equal to MC delta T, and the other formula was Q is equal to ML. If you remember it well, this formula was used for heating / cooling, and this formula is for phase transformation. Tell me which formula is applicable here.
Heating.
Is it
MC
equal to
delta T.
MC delta T or
MC
equal to
cooling.
ML?
Delta T.
MC delta T, because this is the case of heating. यहाँ पर कोई phase transformation नहीं हो रहा. Do you agree with me?
Yes, sir.
Pakka? Okay, beautiful. Now we will solve it for the case A, for the object A. If I use the formula Q is equal to MC of A into delta T of A. Now, in this case, Q is Q, the mass is 1 gram. Specific heat of A, I don't know, but the change in temperature of A is 3 degrees Celsius. Do you agree?
Yes,
sir.
Yes,
Yes, sir.
In the case of B, again, I'll be using the formula Q is equal to mCB delta T of B. Now, heat is Q, the mass is 1 gram, the specific heat is CB, whereas the change in temperature is 5 degrees Celsius. Do you get this?
Yes, sir.
Okay. Let this be equation number 1 and let this be equation number 2. Now, I want you to divide equation. I want you to divide equation 1 divided by 2. When you divide equation 1 by 2, what do you get? Q upon Q is equal to 1 gram into Ca into 3 degrees Celsius upon 1 gram into Cb into 5 degrees Celsius. Do you get that?
Yes, sir.
Yes.
I have divided both the equation. Now, when you look at this, there will be cancellation. 1 gram will cancel with 1 gram, Q will cancel with Q, and degree Celsius will cancel with degree Celsius. And what do we get? 1 is equal to 3 Ca upon 5 Cb. And this gives me that Ca upon Cb is equal to 5 upon 3. Do you get this?
Yes, sir.
Yes, sir.
What does this mean? It answers the first question that Ca is greater than Cb.
Yes.
So obviously first question is answered. And by what factor? Ca is greater than Cb by a factor of 5 by 3. Agree?
Yes.
Yes.
Beautiful.
Yes.
Now
Yes,
I
sir.
want you to look at the complete solution and tell me if there is anything that you don't understand in this.
Sir, how CA?
Ca is greater than Cb? Beta, now if you look at the right hand side, the numerator is 5, the denominator is 3. Is that okay?
Yes.
So can I say that numerator is greater than denominator on the right hand side? By that logic, even on the
Yes,
left hand
sir.
side, the numerator has to be greater than denominator. So if 5 is greater than 3 on the right hand side, then on the left hand side, Ca will become greater than Cb.
Sir,
Yes, beta.
sir, you can put that CB on the right hand side also, no?
Ha, chalega. It doesn't matter. That's pure mathematics. Is this clear?
Yes.
Yes, sir. Yes.
Beautiful.
Yes,
Can I go on
sir.
to the next question?
Yes, sir.
Okay. All right. Let's
Yes,
take
sir.
up the next question. Let's take up the next question. And the next question says, the next question is question number 9. B. The question says, liquid ammonia is used in ice factory for making ice from water. Liquid ammonia is used in ice factory for making ice from water. You know what is the purpose of liquid ammonia? How ice is formed from water? The process is, in this case, what exactly will happen? Liquid ammonia is used in ice factory to form ice from water. Now, if you want to form ice from water, tell me do you need to add heat or do you need to remove heat?
Remove it.
Remove heat.
Remove it.
Beautiful.
Remove heat.
So in this case, heat will be removed. Or I'll rather say, in this case, heat will be released. Do you agree with me?
Yes.
Yes, sir.
Yes.
Beautiful. Now, but why will water release heat? Water will release heat because liquid ammonia will take that heat from water. Water
Yes, sir.
will release heat because liquid ammonia will take that heat from water. What exactly happens is the heat removed or released from water goes to liquid ammonia. The heat released goes to liquid ammonia, and liquid ammonia vaporizes. It gets converted into ammonia vapor. Now tell me, if liquid ammonia wants to get converted into ammonia vapor, then in that case, will it absorb heat or will it release heat? Dhyan se. Liquid ammonia
Release it.
wants to get converted into
Absorb.
Absorb it.
Absorb.
Absorb it.
Absorb
Absorb it.
heat.
So can I say
Absorb,
that
absorb.
heat will be absorbed? Do you agree with me?
Yes.
Yes.
Now the common thing is there has to be something that should connect both the phenomena. Water is releasing heat, liquid ammonia is absorbing heat. So इसका मतलब क्या है? Liquid ammonia ने water में से heat निकाला था.
Yes.
Yes, sir.
If you look at this carefully, what you understand is water releases heat and liquid ammonia absorbs heat. What does this mean? This implies that liquid ammonia extracted heat from water. Do you agree with me?
Yes,
Yes.
sir.
Now do you understand
Yes,
कि ice
sir.
factory में ice कैसे बनता है?
Yes, sir.
Yes, sir.
Beautiful. Now, if you remember the principle of calorimeter said that heat released is equal to heat absorbed.
Yeah.
Do you agree with me?
Sir, if we write gained or absorbed,
Yes.
Mike, put off your mic. Okay. So the principle of calorimeter says that heat released is equal to heat absorbed. ये clear है सबको?
Yes, sir.
Yes,
or
sir.
no? Okay. Now
Sir,
I am going to, yes beta,
sir, I have a doubt.
bolo.
Sir, liquid ammonia has less heat than water.
Are you talking about specific heat?
No, miss, sir, because if liquid ammonia is absorbing the heat, it will have less heat. Now that's why it's absorbing
No,
the heat.
it will have less temperature beta.
Less temperature.
Less temperature,
Okay.
not less heat. जिसका टेम्परेचर कम होता है वो हीट लेता है, जिसका टेम्परेचर ज्यादा होता है वो देता है. Does that answer your question?
Yes, sir. Yes, sir.
Okay. Now, if you read the question further, acha, by the way, in this case, water getting converted into ice, is this phase transformation or heating or cooling case?
Phase
Phase
transformation.
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 Beautiful.
Phase
This
transformation.
is basically a case of phase transformation. Acha, liquid ammonia getting into ammonia vapor, is this a case of phase transformation or
Yes.
heating or cooling?
Phase
Phase
transformation.
transformation.
And phase transformation mein beta, what is the formula? Q is equal to MC
Q
delta
is
T or
ML.
ML?
ML.
ML.
So now we will solve this one by one. We will solve this one by one. कैसे करेंगे? First, I'm solving this case. The formula is going to be Q is equal to M into L, right?
Yes.
Yes,
Okay.
sir.
So can I say that in this case, I will say that Q released will be equal to
पैसा
m, which
मिलेगा,
is
पैसा
1 second,
मिलेगा, 100
mic
रुपए
बंद
मिलेगा,
रखो,
100 रुपए मिलेगा, 100
mic बंद
रुपए
रखो.
चाहिए.
Sir, I think he is doing this purposely.
See, someone is trying to do this
Yes,
purposely.
sir.
I think it is Pradnesh. If the teachers are there on the line, I would request them to take strict action against Pradnesh, because while he was saying this, I noticed his mic was open. Pradnesh, I'm so sorry, beta. I'll have to remove you from the session. See, please don't spoil this, sir. Please don't spoil this. I know you are very smart. I know you are very cool. I know you have got a lot of energy in your body, in your head. You are just 15 years old. Please don't do anything which is of this stupidity level, because my and your time is important. Your exams are coming up. Please don't do this. This is very bad. Now, and in case you really need 100 rupees, कोई दिक्कत नहीं है. It's a very small amount. ठीक है? Go and ask from parents. You know, raise fundraising चला दो, Facebook पे मिल जाएगा. Please don't do this, sir. Not in the session. It's pathetic. Okay. Now, what you can see is कि water is getting converted into ice and heat is released. So can I use the formula that Q released is equal to mass M, which got converted into mass M, which got converted from water to ice, into, in this case, I'll be using latent heat of fusion for ice. Do you agree with this?
Sir, can you repeat?
So can you repeat?
Yes. Obviously, somebody created a disturbance, so I will come again. Now, when you look at this particular formula, water getting converted into ice, this is a phase transformation. Phase transformation has a basic formula of Q is equal to ml, right?
Yes, sir.
Now, in
Yes,
this case, I'm writing a little modified version of the formula. This Q, I'm writing it as Q released. Do you agree with me?
Yes.
Yes,
This
sir.
was released. This M is basically the amount or the mass of water that got converted into ice. Agree?
Yes, sir.
Yes.
Two. In this case, the L will be latent heat of fusion for ice. Agree?
Yes.
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 Beautiful.
Yes, sir.
Yes,
Now
sir.
I'm applying the same concept here. Again, we'll be using the formula, which is Q is equal to M into L. Again, I'll be using this formula only. But in this case, this Q will be Q absorbed. Agree? When we are trying to convert liquid ammonia to liquid vapor, right?
Yes, sir.
Yes, sir.
And this will be the mass of ammonia. The mass of ammonia that got converted from liquid to vapor. Agree?
Yes, sir.
Yes, sir.
Multiplied by the latent heat of, in this case, should I use fusion or vaporization?
Vaporization.
Vaporization of ice, vaporization of water or ammonia?
Ammonia.
Bas, problem solve ho gaya. Now, if you look at this very carefully, don't you think that as per principle of calorimeter, Q absorbed is equal to Q released?
Yes.
Yes, sir.
So
Yes,
what
Yes,
does
sir.
this mean? This means that this value will be equal to this value. Baat samajh mein aaya?
Yes.
yes, sir.
Beautiful. Now look at the value that you've got. If you see, if water at 20 degrees Celsius. Acha, isme there is one more thing that we need to add. Because of the disturbance from the crowd, I got distracted. So I will need to add one more thing here. Now, if you noticed, then water was at what temperature? It was at 20 degrees Celsius, right?
Yes, sir.
Yes.
Yes.
So water was at 20 degrees Celsius. So I will have to incorporate that point which I missed thanks to the disturbance created in the session. That point got completely missed. I'll have to solve this question once again. Okay. Now, when you look at this, water at 20 degrees Celsius is getting converted into ice at 0 degrees Celsius, right?
Yes, sir.
Yes, sir.
Yes.
Now, tell me,
Yes, sir.
हमने heating curve के बारे में पढ़ा था. When you convert water at 20 degrees Celsius into ice at 0 degrees Celsius, the process will be, first water will cool down. First, water will go from 20 degrees Celsius to 0 degrees Celsius. So we will have water at 20 degrees Celsius to water at 0 degrees Celsius. And then this will convert into ice at 0 degrees Celsius. Do you agree with me?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Yes,
This is
sir.
what we miss. But this phenomena is cooling, right?
Yes.
Yes.
And this phenomena
Yes.
is basically phase transformation,
Yes, sir.
Yes,
Yes.
sir.
right? Okay. Now, cooling will have the formula which is
MC
MC
delta T.
delta T, right?
MC delta T.
MC delta T.
Let's say that value was Q1, and phase transformation will have the formula, let's say Q2, which is M into L, right?
ML.
Yes, sir.
Okay. Now, in this case, this can be rewritten as Q released 1, and that will be the mass of water into C of water into change in temperature, and that particular change in temperature is 20 degrees Celsius. Do you agree with me?
Yes, sir.
Yes, sir.
Yes, sir.
And this formula can be written as Q released 2 is equal to the mass of, again, the water that converted to ice into the latent heat of fusion of ice, or latent heat of fusion of water. Do you agree with me?
Yes.
Yes, sir.
Great. So this
Yes.
is one point that we missed in the previous part. Now, when you look at this, can I say that as per the principle of calorimeter, can I say that the heat absorbed by ammonia is equal to the heat released by water, and the heat released by water are coming into two parts, first Q1, second Q2. Do you agree with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Beautiful.
Yes, sir.
Now, the heat absorbed, pay very high attention, the heat absorbed by ammonia will be written as the mass of ammonia into latent heat of vaporization of ammonia is equal to Q1. Q1 is the mass of water into the specific heat of water into the change in temperature plus the mass of water that got converted into ice into latent heat of fusion of water. Agree?
Yes,
Yes.
sir.
Yes,
Beautiful.
sir.
In this
Sir,
particular question, yes, beta?
sir, I have a doubt. In ammonia, first its temperature will increase, no?
No, beta, ammonia is a very interesting liquid. Ammonia will immediately get transformed into vapor because ammonia is already at its vaporization point. For example, if you heat water at 100 degrees Celsius, will its temperature increase or it will transform into vapor?
It will
It will
transform.
transform into vapor.
Transform to
Ammonia
vapor.
will immediately transform into ammonia vapor. Agree?
Yes, sir.
Okay. Now let's put the values and solve the question. Now, what is the amount of water we have? What is the amount of water do we have?
2
Water
kg.
kitna hai?
2
2
kg.
kg. But we always stick with gram and calorie. We
Gram.
always stick with what? Gram and calorie. So 2 kg will be given as
2000
2
grams.
kg will be given as 2000
1000 grams.
grams. Very good. What is the specific heat of water?
1.
1.
1.
But 1
1.
what? 1 calorie
1
per
calorie per
gram
gram
quantity
degree
1
Celsius.
calorie.
into What was the temperature change of water? 20 degrees Celsius.
20
Na?
degrees
20
Celsius.
20 degrees Celsius.
Beautiful. Now, again, what is the mass of water? 2000.
1000.
What is the latent heat of fusion? 80.
80.
Remember?
80.
80.
Beautiful. Now, what is the mass of ammonia? Don't you think this is what needs to be calculated, right?
341.
Into what is the latent heat of vaporization of ammonia? They have given you the answer. It is
341 calorie.
341
calorie per gram.
Therefore, when you solve this question, you get the answer as the mass of ammonia. Put off your mic. The mass of ammonia is equal to 2000 into 20 plus 2000. Acha, I can take 2000 common, na? If I take 2000
Yes.
common, then I will have 20 plus 80, which is 100, right?
Yes,
Yes,
sir.
sir.
Upon 341. Is that
Yes.
okay? Now, when you
Yes.
solve this, you get the answer as 586.4 gram. I hope you know how to do calculations.
Yes, sir.
Yes.
Yes.
Now, what I want is you
Yes.
can zoom your screen and look at the complete solution at once and understand the concept. I will give
So
you
do
2
we have to
minutes
write
to see
this?
the solution. What, beta?
So do we have to write this?
You don't need to write this. I'll send you the PDF. But see, you understood the concept, right? You understood the whole sketch. अमोनिया
Yes, sir.
लिक्विड अमोनिया ने वाटर से हीट लिया, लिक्विड अमोनिया ने वाटर से हीट लिया, खुद को वेपराइज किया, लेकिन जब वाटर से हीट लिया तो वाटर ठंडा हुआ, 20 से 0 डिग्री पे गया और 0 से आइस में कन्वर्ट हो गया. डू यू अंडरस्टैंड द कॉन्सेप्ट नाउ?
Yes.
एब्सोल्युटली. बट वी नो कि प्रिंसिपल ऑफ कैलोरीमीटर क्या बोलता है? हीट रिलीज्ड इज इक्वल टू हीट एब्सॉर्ब्ड, यानी कि द हीट एब्सॉर्ब्ड बाय लिक्विड अमोनिया इज इक्वल टू द हीट रिलीज्ड बाय वाटर. बट वाटर ने हीट को 2 स्टेप में रिलीज किया. फर्स्ट कूलिंग, सेकंड फेज ट्रांसफॉर्मेशन. Do you agree with me?
Yes, sir.
Beautiful. Do you have any doubt in this question?
No, sir.
No, sir.
No doubt.
Now, how do you exactly write this on a paper? You write the solution as it is given in the guide. Let's say Navneet or any other guide. You need to mention theory. Let the mass of ammonia be M. Let the latent heat of vaporization be LV.
Kevin.
Let the mass of 1 second. Put off your mic, beta. Put off your mic. Put off your mic. Put off your mic. Okay. So how do you exactly solve this particular question? You write it as let the mass of ammonia be M. Let the latent heat of vaporization be LV. Let the mass of water be, let's say, M dash. Let's say let the specific heat of water be CW. Let the change in temperature of water be delta T. Let the latent heat of fusion of water be LF. Now write the values of all. Show the principle of calorimeter. Heat released is equal to heat absorbed. Write individual formula. Make the equation. Start the calculation. Give the final answer. Do you get that?
Yes, sir.
Yes.
So you need to,
Yes,
the
sir.
sketch,
Yes,
the
sir.
thought that I've given you, you need to convert this into your own English language, and you can use the reference of guide for this. Can we move to the next question?
सर
Yes, sir.
Yes, beta.
सर अगर टेम्परेचर नहीं दिया होता तो हम लोग Q इज इक्वल्स टू ml से ही जाते ना.
Yes. ना अगर टेम्परेचर नहीं दिया होता तो हम सॉल्व ही नहीं कर पाते, क्योंकि 20 डिग्री सेल्सियस नहीं दिया तो कैसे पता चलेगा कि कूलिंग कितनी हुई. अगर ऐसा होता कि वाटर पहले से 0 पे होता तो अपन क्या लगाते? Q इज इक्वल टू ml, क्योंकि उसमें तो कूलिंग ही नहीं हुआ, सीधा कन्वर्जन हुआ. डू यू गेट दैट?
तो सर
एक सेकंड बेटा, मैं वो उनका क्वेश्चन एड्रेस कर लेता हूं. नाउ बेटा, लेट्स से वाटर वाज नॉट एट 20 डिग्री सेल्सियस, वाटर वाज एट 0 डिग्री सेल्सियस. So in that case, water will not cool, water will get transformed into ice. Then Q is equal to ml. But in this case, water is at 20 degrees Celsius. So first water will cool, then it will get transformed. Does that answer your question?
Yes, sir.
Okay, next question, very quickly.
सर
हाँ
सर अगर है ना मतलब वो 20 डिग्री सेल्सियस नहीं दिया जो आप पहले सॉल्व करा था ना, जिस मेथड से आप सॉल्व करा रहे थे
हाँ
पहले,
हाँ हाँ, अगर 20 नहीं होता, 0 होता तो पहला
तो
मेथड
फिर
काम आ जाता.
तो हम सर गलत मेथड यूज कर रहे थे उस समय, पहले आप जो
उस
करा था।
समय I'll tell you what exactly happened. उस समय I got distracted because of this, you know, जो भी chaos हुआ ना थोड़ी देर पहले. So I got a little distracted and I forgot to read कि वहाँ 20 डिग्री सेल्सियस दिया हुआ है.
हाँ, तो अगर सर नहीं होता
तो फिर तो मैं जीरो वाला करता.
ठीक है सर.
Get that point?
Yes sir.
Beautiful. Can I move on to the next question?
Yes, sir.
मजा आ रहा है, समझ में आ रहा है एकदम अच्छे से हुआ क्या था, पूरा पिक्चर समझ में आया?
Yes, sir.
Yes,
Yes,
sir.
sir.
Beautiful. Let's
Yes,
go to the
sir.
next question. Let's go to the next question now. Now, what does the next question say? C part, question number 9, and we have C. Question number 9C में, put off your mic, beta. A thermally insulated pot. Beta, a thermally insulated pot. 1 second. Please put off your mic. Half of my time is wasted into putting off your mic all the time. Okay. What they have given, ध्यान से देखना. They have given a thermally insulated pot. Acha, by the way, a thermally insulated pot, don't you think it's a calorimeter?
Yes sir.
Yes, sir.
Yes. Yes, sir.
ध्यान से देखना. There is a thermally insulated pot. We have got a thermally insulated pot. This pot has a mass. Okay, there is a thermally insulated pot, which is nothing but a calorimeter. Now, inside this pot, we have got 150 gram of ice at 0 degrees Celsius. So inside this pot, we have got 150 gram of ice at 0 degree Celsius. Okay. How much steam at 100 degrees Celsius is to be mixed to it so that the water of temperature 50 degrees Celsius is obtained? Now, what they've said is we need to mix. Beta, please put off your mic. Everybody, please put off your mic. I'm allowing you to speak so that we have an interaction, a proper interaction, right? Otherwise, you'll not be able to ask me doubts. Now, यहाँ पर है ना दो चीजों की mixing हो रही है, ध्यान से देखना. It has ice at 150 gram at 0 degrees Celsius, and this is mixed with what? This is mixed with steam at what temperature? 100 degrees Celsius.
100 degrees Celsius.
Are we good?
Yes,
Yes,
sir.
sir.
No.
Yes, sir.
And after mixing these two, what do we want? We want water at 50 degrees Celsius. Do you agree?
Yeah.
Yes, sir.
Yes
Now
sir.
the question is how much steam? Let's say m gram of steam. So my problem will be about finding the value of m. Do you agree with me?
Yes.
Okay.
Yes.
Finally, the water will be, don't you think the water will be nothing but 150 plus m gram? Because 150 gram was
Yes.
ice, m gram was steam. Are we clear with this?
Yes, sir.
Yes, sir.
Now, if you are clear with this, now I am going to give you a Brahmastra. How do you solve such problems? See, I'm going to make a line diagram. I am going to make a line diagram. Is everybody muted? Okay, everybody is muted. How do I make a line diagram? See, Acha, what is the highest temperature that you can see? 0, 100 or 50?
100.
100.
100
Make
each.
a line diagram and write 100 degree Celsius. Now, is 100 degree Celsius a normal temperature or it's a phase transformation temperature?
Phase
Phase
transformation.
transformation.
Make one line, make
Transformation
two lines. Yes.
temperature.
Don't make one line, make two lines. One will represent steam, the other will represent water. Agree?
Yes.
Yes.
Yes, sir.
Beautiful.
Yes, sir.
And then you also have 0 degree Celsius. Okay, so make a 0 degree Celsius. Make plot the highest temperature, then plot the lowest temperature. 0 degree Celsius. By the way, beta, 0 degree Celsius, is it a normal temperature or a phase transformation temperature?
Phase
Phase
transformation.
transformation temperature.
Transformation.
Make
Ice and
two
water.
lines. Beautiful. Yes, yes. Very smart. So now you're getting the logic. So 0 degree Celsius, one will represent water, the other will represent ice. I hope you're smart enough to understand कि मैंने water के नीचे ice क्यों लिखा था और ऊपर water के ऊपर steam क्यों लिखा था.
Yes.
Yes, sir.
Yes, sir.
Amazing. And finally, you see what we have got. We have got water at 50 degrees Celsius. So make that 50 degrees Celsius ka line. And at 50 degrees Celsius, you have got water, right?
Yes, sir.
Agree? Okay. Now plot it. जो चीज जहां पर है वहां पर रख दो. 150 gram of ice was at 0 degrees Celsius. So don't you think I should be putting 150 gram of ice here?
Yes, sir.
Because it is ice. Clear?
Clear.
Yes.
Okay.
Yes.
M gram of steam is at
Yes, sir.
100 degrees Celsius. So don't you think I should be putting M gram of steam here at 100 degrees Celsius? Yes or no? Beautiful. Now, let me tell you, in this case, don't you think steam will release heat and ice will absorb heat? Agree?
Yes, sir.
Yes, sir.
Steam will release heat and ice will absorb heat. Now, if steam is releasing heat, will its temperature come down or go up?
Come down.
Decrease.
Come down.
Down.
Come
So
down.
don't you think? Acha. Now try to understand. Steam will first get converted into water, right? So this will be step number 1,
Yes.
isn't
Yes,
it?
sir.
And then that water will cool down to 50 degrees Celsius, right?
Yes. Yes, sir.
So don't you think I can say that this is Q released 1 and this is Q released 2?
Yes, sir.
Yes, sir.
Beautiful. Now, ice will absorb heat. So don't you think that ice will go up?
Yes, sir.
But the absorption will happen in 2 steps. First, ice will get into water, which is Q absorbed 1, and water will get heat up to reach 50 degrees Celsius, which is Q absorbed 2. Do you agree with me?
Yes.
Yes, sir.
Beautiful. Now, let us write down the value of these things, okay, one by one. First, I will write down the value of Q released. Q released 1. In the case of Q released 1, should I use the formula MC delta T or ML?
ML.
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 Beautiful. So M into L. But what should I use? Vaporization or fusion?
Vaporization.
Fusion.
Fusion.
Vaporization, beta. Steam to water.
It's fusion.
Steam to water. Water to steam. Vaporization. Remember?
Yes, sir.
You released 2.
MC delta
Now
T.
in this,
MC
yes,
delta.
beautiful. In this case, is there phase transformation or cooling?
Cooling.
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 It's going to be MC of water into delta T. MC of water into delta T. Agree?
Yes.
Yes, sir.
Yes.
Okay.
sir.
Yes, sir.
तुम्हें एक चीज का यहाँ पर ध्यान रखना है. Now, one point to be noted here is in this method, delta T should be positive. It should always be higher minus lower. It should always be higher minus lower. Please remember this. Now, M. What is the latent heat of vaporization? It is 540. Agree?
Yes.
Yes, sir.
M.
Yes.
What is the value of CW? 1. What is delta T? 100 से 150 100 से 50 आ गया. It is going to be
50,
100 minus 50, which is very nice. Now let us write Q absorbed. Q absorbed 1. What should this be? Should
M-
this be
M
MC
latent heat.
delta T or ML? ध्यान से. Q
ML,
absorbed
ML.
what? Ice to water.
ML.
ML. But यहाँ
ML.
पर M का value तो 150 है. Into what is the value? Should it be LF or LV?
LF.
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 And LF का value is 80. Clear?
Yes.
Yes, sir.
Yes.
Very smart. Now Q absorb 2. Is it heating? Now Q absorb 2. Do you find Q absorb 2 as a phenomena of melting, phase transformation, or heating?
Heating.
Heating.
What should be the formula?
Delta T.
MC delta T.
MC into delta T, which is 50 minus 0, right?
50.
Higher minus lower. So again, it's going to be 50. Do you agree with me?
Yes, sir.
Sir.
Beautiful. Now, the principle says Q released is equal to Q absorbed. The principle says Q released is equal to Q absorbed. But don't you think that Q released was in 2 steps? Q released 1, Q
Yes.
released 2, and Q absorbed was in 2 steps. Q absorbed 1, Q absorbed 2, right?
Yes.
Therefore, what do I have is Q released 1, which is 540 M plus 50 M is equal to 150 into 80 plus 150 into 50. Do you get that?
Yes, sir.
Yes, sir.
Now this becomes 590 M is equal to 150 common nikala. 80 plus 50 is going to be 130, right?
130.
So M is going to be 150 into 130 upon 590. And when you solve this, you will get M is equal to 33 gram approximately. Simple tha?
Yes, sir.
Yes.
Now look at the complete solution at once.
So doubt, sir, doubt.
Yeah. Sure. If you have any doubt, you can raise it. Tell me, beta.
Hello.
Ha, beta. Please ask me your doubt.
Sir, how can we will first multiply 150 into 80 now. How can we? So how come 130 came?
नहीं, इसमें I took 150 common and 80 plus 50, which is 130. You can
Okay,
take
yes,
150 common na beta.
So
Is
I
that
was
okay?
thinking of board mass. Yes.
Abhi clear hai?
Yes, sir.
Okay. I'm giving you 2 minutes to think on this. And if there is anything that you don't understand, please ask me. But do you find this very interesting?
Yes,
Yes,
sir.
sir.
Do you find this very simple?
Yes, sir.
Ekdam simple hai. Heat released is equal to heat absorbed. You should know how to write heat released. You should know how to write absorbed. Now, ये जो मैंने line diagram बनाया है ना, please remember this. This is what makes this problem very, very easy. Otherwise, this problem is not that easy. जब इसको पहले किया था तो क्या इतना आसान लगा था?
नहीं.
No, sir.
अब लगाना, because the line diagram is very helpful. It's very, very helpful. Another
Sir?
60 seconds. Yes, beta.
Sir, can you explain that Q absorb 2?
Q absorb 2. See, if you look at Q absorb 2, I will zoom this. See, Q absorb 2 is the case of heating. And we know that heating has a formula of MC delta T. The mass of ice was 150. The C of water was 1. And the change in temperature is 50. 0 se 50, yani change is 50.
Okay, sir.
MC delta T. Clear?
Yes, sir.
Okay. Any more doubt, or can I move to the next question now?
Next question.
Thank you. Let's move on to the next question. Moving on to the next question now, we will take the last question, which is question number 9. D. What does the question say? A calorimeter has a mass of 100 gram. तुमने देखा यहाँ पर कैलोरीमीटर का मास बता दिया. इसका मतलब कैलोरीमीटर पार्टिसिपेट करेगा हीटिंग में. I am putting off the mic. Sujal, why have you started your mic? Okay. मुझे एक बात बताना. See, even the perfect calorimeter can also absorb and release heat. For example, the thermal or thermos that you carry in winter, you will find that that particular thermos also gets hot after a point of time, isn't it?
Yes, sir.
Yes.
Yes.
Because that thermos can also participate, right? वो भी तो हीट एक्सचेंज कर सकता है ना, आखिर में तो
Yes.
सब्सटेंस है. इसका मतलब कैलोरीमीटर भी पार्टिसिपेट कर सकता है.
Yes.
Yes.
So
Okay.
this particular question, calorimeter will also participate. And how will calorimeter participate? I'll tell you. They have written it as a calorimeter has a mass of 100 gram and specific heat of 0.1 kilocalorie. So we have a calorimeter. We have a calorimeter which has a mass of 100 grams and it has a specific heat of 0.1 kilocalorie per kg per degree Celsius. Is this okay?
Yes, sir.
Now, this calorimeter, it contains 250 gram of liquid. Yani this calorimeter is going to participate with some liquid. This calorimeter is going to participate with some liquid, and that particular liquid is of 250 gram, and that liquid has a specific heat of 0.4 kilocalorie per kg per degree Celsius, and that liquid is at 30 degree Celsius. Do you agree with me?
Yes.
Yes, sir.
Yes.
Okay. Now they have said if we drop a piece of ice, यानी इसमें ice भी आ गया. So now I have ice. So if we drop a piece of ice which has a mass of 10 gram, and ice is at 0 degree Celsius. So don't you think in this case there are three things which are mixing, which are participating? Calorimeter, liquid and ice, three things are participating. Agree?
Yes, sir.
So now this can be written as, this is the mass of calorimeter, this is the mass of liquid, this is the mass of ice, this is the specific heat of calorimeter, this is the specific heat of liquid. Now specific heat of ice, we know it is 0.5 calorie per gram per degree Celsius, and we also know that the latent heat of fusion for ice is 80 calorie per gram per degree Celsius. Agree?
So for fusion, it will be not a degree Celsius.
Oh, I'm very sorry. Thank you for correcting me. It will be 80 calorie per gram. ठीक है? Now, यहाँ पर
Yes,
एक
sir.
चीज ध्यान देना. यहाँ पर you know the temperature of liquid, you know the temperature of ice, but you don't know the temperature of calorimeter, right?
Yes.
You need to be very smart. Now the question is, अगर मैं एक बर्तन में एक पानी को भर दूं और काफी समय तक छोड़ दूं, तो बर्तन और पानी का टेम्परेचर सेम होगा ना?
Yes, sir.
Yes. Yes.
So I think you're smart enough to understand that the temperature of calorimeter was supposed to be 30 degrees Celsius because liquid was poured in calorimeter for a long time. बात समझ में आया सबको?
सर
Yes.
Yes बेटा.
सर लेकिन लिक्विड का जो टेम्परेचर था वो पहले 30 डिग्री था ना,
नहीं
तो
see
जब
what exactly
कैलोरीमीटर में
happened
जाएगा
was,
तो
मैं बताता हूँ. The question says that a calorimeter already contains the liquid at 30. ध्यान से पढ़ो. Calorimeter already has 250 gram of liquid at 30 degree Celsius. Clear हुआ?
हाँ सर हाँ.
हाँ. अच्छा, इसमें ना एक चीज है ना जो थोड़ा सा कंफ्यूजन क्रिएट कर सकती है कि सर अभी तक तो कैलोरी पर ग्राम पर डिग्री सेल्सियस आ रहा था, अचानक से वी हैव किलो कैलोरी पर केजी पर डिग्री सेल्सियस. कोई बात नहीं बेटा, इसको सिंप्लीफाई कर लो. किलो का मतलब 10 की पावर 3 कैलोरी, केजी का मतलब 10 की पावर 3 ग्राम डिग्री सेल्सियस. दोनों कट गए, इसका मतलब क्या है? दिस इज ऑल्सो कैलोरी पर ग्राम पर डिग्री सेल्सियस. अग्री?
Yes, sir.
Yes.
इसका मतलब क्या है? यहां पर के का कोई सिग्निफिकेंस नहीं है. नाउ लेट्स स्टार्ट द क्वेश्चन. अब शुरू करते हैं, ठीक है? सब लोग ध्यान देंगे। मैंने तुम्हें लाइन डायग्राम सिखाया है ना, सबसे हाईएस्ट टेम्परेचर कौन सा है?
30
30
degree.
degree Celsius.
30 डिग्री सेल्सियस। अच्छा, 30 डिग्री सेल्सियस क्या फेस ट्रांसफॉर्मेशन वाला है या नॉर्मल टेम्परेचर है?
Normal.
Normal.
Normal temperature.
सो वी आर नॉट सपोज टू मेक 2 लाइंस, एक सिंगल लाइन काफी है?
Yes, sir.
Yes.
Yes.
Yes, sir.
वेरी गुड। सबसे लोएस्ट टेम्परेचर कौन सा बेटा?
0 degree
0 degree
Celsius.
Celsius.
0 डिग्री सेल्सियस। नाउ
Phase transformation.
exactly, so we will make 2 lines.
2 lines.
This one for ice, this one for water. Beautiful. Now plot it. जो जहां पर है उसको वहां पर उठा के रख दो। 30 डिग्री सेल्सियस पे वी हैड कैलोरी मीटर। 30 डिग्री सेल्सियस पे वी हैड कैलोरी मीटर, राइट? सो 30 डिग्री सेल्सियस पे वी हैड कैलोरी मीटर, तो कैलोरी मीटर को यहाँ रख दो। सो वी हैव यहाँ पर कैलोरी मीटर। बट 30 डिग्री सेल्सियस पे वी ऑल्सो हैव लिक्विड।
Liquid.
Do you agree with me?
Yes.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, beautiful. Now, pay attention. I will need thoda more space here. Now, 0 degree Celsius पे we have ice. तो यहाँ पर what do we have? I think you're smart enough to understand that we have ice here. Agree?
Yes.
Yes,
Yes.
sir.
Now, finally, what will happen is, we know that calorimeter will come down, liquid will come down, and ice will go up. Do you agree with me?
Yes,
Yes,
sir.
sir. Yes.
They will achieve a common temperature called as T. Smart enough to understand?
Yes, sir.
Yes, sir.
But if you notice this, then this will be cooling, this will be cooling, this will be phase transformation, this will be heating. Smart enough?
Yes.
Yes, sir.
Yes,
So
sir.
can I say this will be Q released 1, this will be Q released 2, this will be Q absorbed 1, this will be Q absorbed 2. Yes
Yes,
or
sir.
no? Any doubt so far? This is the last question.
No.
Any doubt so far?
No, sir.
No.
Sir.
No, sir.
Beautiful, beautiful, beautiful. Now we are going to write these values very smartly. Dekho. Now when we write these values, what do we get? Acha, Q released 1. What will be the formula? Is this a case of phase transformation or it's a case
MC
of cooling?
delta T.
Heating.
MC
MC
delta
delta
MC
T.
delta T. But this will be mass of calorimeter, C of calorimeter, and delta T. Delta T will be, I have always told you,
30
higher
minus
minus lower.
30
Higher
minus
minus
T.
lower. So it will be 30
30
minus
minus
T.
T.
Always higher minus lower. Okay. Q released 2. That will be mass of liquid, C of liquid, and again higher minus lower. Do you agree with me?
Yes,
Yes.
sir.
Yes, sir.
Now, Q absorbed 1. MC delta T or
ML.
ML?
ML.
Very nice. ML.
ML.
And that will be mass of ice, latent heat of fusion of ice. Into delta T. यहाँ पर delta T नहीं आएगा. ये तो ML है. There is no delta T. Right?
Yes.
Q absorbed 2 will it be MC delta T
delta
or
T.
ML?
MC delta
MC
T.
delta T.
MC delta C. So now this will be called as mass of ice मत बोलो, इसको mass of water बोल दो, because ये ice water बन चुका है. And that will be C of water into delta T. Higher minus lower. Should I write 0 minus T or T minus 0?
T minus
0.
Minus 0.
Very smart, very smart. चलो अब इन सब की values put करते हैं, ठीक है? So now when we write down the values, Q released 1 की value. What is the mass of calorimeter, beta? 100.
100.
What is the C of calorimeter? 0.1. 30 minus T. Okay. Q released 2. Again, what is the mass of liquid? 250.
250.
What is the specific heat of liquid? 0.4.
0.4.
And it will again be 30 minus T. All right. So now Q absorbed 1. What is the mass of ice?
10.
10 grams. What is the latent heat of fusion of ice? 80.
80.
Q absorbed 2. What is the mass of? Acha, don't you think that 10 gram of ice will convert into 10 gram of water only, na?
Yes, sir.
Yes. Yes.
So it will again be 10. But what is the specific heat of water? 1.
1.
What is the change in temperature? Dhyan say, should it be T minus 0, 0 minus T?
T minus
T
0.
minus
Minus
T
0.
minus 0.
Minus 0.
Minus 0.
Now, the principle of calorimeter says us very simply that Q released is equal to Q absorbed. Agree?
Yes, sir.
Yes. Yes, sir.
It will be in terms of two ways, QR1, QR2, and Q absorbed will be in two steps, QA1, QA2, right?
Yes, sir.
Please write down the values. When you write down the values, what do you get? We get by 100 into 0.1. By the way, I think I can take 30 minus T as common, na? Isme, ऊपर
Yes.
में.
Yes, sir.
And I will have 100 into 0.1 plus 250 into 0.4. And yahan par, I can take 10 common, right?
Yes.
And I will have 80 plus T. Agree?
Yes, sir.
Okay. So now what do we have is I have 30 minus T. 100 into 0.1 kitna hota hai? 10, right? 10. And 250 into 0.4 kitna hota hai? 100.
100.
100.
So I have 10 plus 100 is equal to 10 into 80 plus T. I will do the calculation here, or I will take this calculation on the next page now. Copy. Paste. So now what do we get here is, therefore, we have 110 into 30 minus T is equal to 10 into T plus 80. So I have 110 into 30. 110 into 30 is 3300 minus 110T is equal to 10T plus 800. So I have this goes here. So I get 120T is equal to 3300 minus 800, right? Therefore, I have T is equal to 3300 minus 800 is 2500 upon 120.
2500.
And this will give you an approximate answer of 20.8 degrees Celsius. Do you get that?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Simple tha,
Yes.
simple tha ekdam. Simple tha.
Yes, sir.
Yes,
No
sir.
difficulty at all.
No, sir.
Look into
No.
the solution and tell me if you have any doubt.
No, sir.
No, sir.
You don't have any doubt?
Sir,
No, sir.
Crystal clear.
Yes.
Yes, beta.
Yes.
Tell me if you have any doubt.
सर latent heat of fusion मतलब कितना heat चाहिए रहेगा ice को water को
Yes,
ice को
the amount of heat required to break ice ka bonds so that it gets converted into water at 0 degrees Celsius is called as latent heat of fusion.
okay और वही सर अगर latent heat of fusion of water होता तो
सेम चीज ना, ये
अच्छा
रिवर्सिबल है ना बेटा. हीट
Okay,
करूंगा
sir.
तो आइस से वाटर 80 कैलोरी लगा हर ग्राम को. कूल
Okay,
करूंगा
sir.
तो वाटर से आइस तो 80 कैलोरी लगेगा ना. आई गेव यू 100 rupees, you became rich. I will take 100 rupees back, you became poor.
yes sir.
Is this clear?
Yes.
Yes, sir.
So
All right. So if this is clear
Sir?
to you, हाँ बेटा, please tell me.
सर ये लैटेंट हीट ऑफ फ्यूजन में 80 कैलोरी कैसे आया?
बेटा ये स्टैंडर्ड है. This is a standard value that you need to use always, forever.
ओके सर.
It's a standard value that you'll have to always use.
Excuse me, sir.
Yeah बेटा.
Can you please show the last solving that you did?
हाँ.
Okay, sir. Thank you.